Hi, I'm an old guy and I do maths. Today we have an intriguing problem. It's a probability problem, and we're going to solve it using the concept of a binomial. Uh, Let me read through the problem and explain a little bit. So, 5 men attend a meeting. There is a 40% chance, that is a probability, that an attendee will wear a suit, which means that there's a 60% probability that they will wear something else. What is the probability that 3 or more wear suits? Now, as I mentioned earlier, this is a binomial problem, and we have a means of dealing with it which involves a couple of things that may be familiar to those who have not even done probability, but you'll recognize one or two things here. So let me just go through what we've got here. The probability that an outcome is something, 1, 2, 3, 0, whatever, is equal to the number of trials, which is n. In this case, it will be 5. There are five people here. Our desired outcome, which in this case is 3, 4, or 5 people wearing suits, times the probability of that outcome to the power of the outcome that we want, which is 3, 4, or 5, times the probability of failure, 1 minus the probability of success. And that is to the power of the number of trials minus the particular outcome that we're looking at. And I'll fill all this in later so you can see how it actually works. Now, breaking this part down, this is a factorial notation which, if you've done something like permutations or combinations, you may have seen. Anyway, this is expanded to this, and that is n factorial, the number of trials, the factorial of that, divided by the desired outcome as a factorial, times the number of trials minus that desired outcome as a factorial. And we do this for 3, 4, and 5 because we are looking at the combined probability that someone is that 3 or more people wear suits. So that's the probability that 3 wear suits, that 4 wear suits, and 5 wear suits. Now, if we think about this and make some rough estimates, the probability that 3 people wear suits is going to be greater than the probability that 4 or 5 do, because there is a 40% chance of someone wearing a suit. So as the number of people wearing suits increases, the chances of that happening becomes ever more remote, because, for one thing, it's less than a 50% chance. But even if it were greater, the chances of 5 people wearing a suit would be less than the chances of 3 people wearing a suit. So that's just something to tip us off to what can go wrong if we suddenly find that the probability of this is greater than that. We've made a mistake. Okay, well, let's set about setting this up, and that's going to take a little bit of time and effort. So just bear with me. I'll get a clean piece of paper and I'll start writing this up. What we're going to do is we're going to start with the probability that our outcome is 3. So here goes. We'll just remove that, and I'll come back and forwards to the formula from time to time. So what we are looking at is the probability that our outcome, large X, capital X, is that, and X equals 3, so it is the probability that our outcome is 3. So let's set this up. So looking at the formula, which, where can I place that? I'll just put this here for the moment. So the first part is this, n choose x, which is how this is said. So n is 5, and 3 is what we're looking for. So that's 5 choose 3. And that is then multiplied by the probability of our positive outcome, which is 0.4, 40%, to the power of that, to the power of x. And then that is multiplied by 1 minus the probability. So I'll do this way just once. Sorry, that is a 4. And that is to the power of our trials minus our outcome, which is 5 minus 3, which is 2. And this is 0.6. So if we work through all of that, what we have is we have 5 factorial over 3 factorial times 2 factorial, and where that comes from is here. Just let me show you that again. N is 5, x is 3, n minus x is 2. And we're going to multiply that by 0.4 to the power of 3, and then 0.6 to the power of 2. Now, let's work this out. Okay, so 5 factorial is 5 times 4 times 3 times 2 times 1. That is over 3 factorial times 2 factorial. And what do we get? Well, we get quite a bit of cancelling, and we wind up with 20 over 2, which equals 10, times 0.4 to the power of 3. 0.4 to the power of 3, which is 0.064. And then 0.6 to the power of 2. Which is 0.36. That's there. Hopefully you can see that. Okay, so let's multiply this up. That is 10 times 0.064 times 0.36, which gives me 0.2304. Now that is the probability under all of these circumstances that 3 people wear a suit. Now we have to do this for 4 people and for 5 people. So let's get to work. So 5, 4, and 1, I think. Yep. And that is going to be 0.4 to the power of 4, because we are looking for 4, and that is 0.6 to the power of 1, which is nice and easy. Now, 5 factorial over these are 5 times 4 times 3 times 2 times 1, Mr. Times there, 4 times 3 times 2 times 1 times 1. Okay, so cancelling. 1, 2, 3. The answer is 5. 0.04 to the power of 4. Sorry, 0.4 to the power of 4. There we are, 0.256. Sorry, 0.0256. It gets smaller. 0.6 to the power of 1 is 0.6. Let's multiply that all up, times 5 times 0.6, which gives me 0.768. 0.0768. I seem to be missing zeros left, right and centre here. My apologies. That is a point in there. Okay, so just to run through this again, 5 factorial over 4 factorial, note the difference, 1 factorial times 0.4 to the power of 4 times 0.6 to the power of 1, success, failure. This gives us 5, that is that, that is that, multiply them up together and we get that. That's our next number. Okay, last one. 5 factorial over 5 factorial times 0 factorial. This is interesting. It's the subject of another video probably, but that's equal to 1. So basically what we've got here is that all cancels. That is 1. 1 over 1 is 1. Now we have 0.4 to the power of 5 times 0.6 to the power of 0. That's also 1, so really we're just concerned about this. 0.4 to the power of 5. 0.4 to the power of 5, which is a very small number, 0.01024. Now, as mentioned earlier, you will notice that these probabilities are getting smaller and smaller and smaller, as we would expect. So, what does this all come to? Well, we'll add this, this and this, and we'll get our answer. Plus 0.0768 plus 0.2304. And the answer is about 32%. It is 0.31744, which we will call a 32% chance that 3, 4 or 5 people turn up in suits to this meeting. That's how this is done. It's a little bit laborious, but it's an intriguing problem, and more importantly, it's an intriguing way of solving a problem. So I hope you enjoyed this and found it interesting. If you did, please like and subscribe, and I will see you next time. Bye.